Welcome. We'd like to consider solving a rational equation that is reducible to a linear equation. We want to begin by observing that we don't want to divide by zero. So we're going to consider the domain of the variable. So we'll say domain. And in particular, we're interested in things that we don't want, right? I can plug in almost anything I want. I don't want to list all of those things. Rather, what I want to do is I want to simply say, I can't have x minus 2 being equal to 0 or x minus 1 being equal to 0. X minus 2 being equal to 0 would make the denominator 0 here, or it would make the denominator 0 here. Similarly, for x minus 1, we would have a denominator of 0 and a denominator of 0. So we can't have those situations. That gives us x being equal to 2 or x being equal to 1. So when we solve this equation, if we find that x is equal to 1 is a solution, we say, oh, no, that's an extraneous solution. It's actually not possible. Okay, so let's see what we end up with. We start with our equation of 3 divided by x minus 2 is equal to 1 divided by x minus 1 plus 7 divided by x minus 1 times x minus 2. Now, what I'd like to do is I'd like to get rid of the fractions, right? We have a bunch of rational expressions being added together, setting equal to, that sort of thing. So what can we do here? If I want to get rid of those, I want to multiply by the least common denominator. Okay, the least common denominator in this case, what would that be? Well, x minus 1 times x minus 2, we need all of that, but that contains the x minus 1 and it contains the x minus 2. So in this case, that is simply the x minus 1 times x minus 2. So what I'm going to do is I'm going to take the left-hand side and I'm going to multiply by x minus 1 times x minus 2. And I'm going to take the right-hand side and I'm going to multiply by x minus 1 times x minus 2. Excellent. So what I'm doing here is I'm multiplying by the least common denominator. And we have a cancellation. We're going to have cancellation of x minus 2 and x minus 2, giving us 3 times x minus 1 is equal to, now we need to recognize that we need to distribute. So we need to distribute this into the brackets here. So distribute to the 1 over x minus 1. We would have x minus 1 times x minus 2 divided by x minus 1. And we have 7 times x minus 1 times x minus 2 divided by x minus 1 times x minus 2. Now, you don't have to show this step necessarily, depending on your comfort level with the process. But now that we've distributed, we can recognize that we do get that simplification again. X minus 1 cancels out with x minus 1, and both of the factors cancel out with both of the factors. Wonderful. So on the left-hand side, I can distribute the 3 into the parentheses to have 3x minus 3 is equal to x minus 2 on the right-hand side plus just the 7 now. So I have expanded, simplified a little bit. Now I can combine like terms. Clearly at this point, I have a linear equation. So I just want to work towards getting all of the x's on one side and all of the constants on the other. So let's see here, a couple steps at once. I'm going to subtract x from both sides to get just 2x on the left. I'm going to add 3 to both sides. So my 7 minus 2 is a 5, and 5 plus 3 is 8. And I'm going to divide by 2 to obtain x is equal to 4. And that's perfectly fine. I like that answer. It does not cause any issues with the domain of the variable. That is not 2, that is not 1. Right, so we're good to go. If you would like to verify your answer, you go ahead and plug it into the original equation and verify that the left-hand side is equal to the right-hand side, and that is fine to do. Thank you for your time.